Welcome back to another one of my applications of differentiation videos. This will be optimization on optimization, and this is the third video. So this video will be focused on fitting a square or a rectangle. We're trying to optimize, that should be a bit over more. We're trying to optimize the size of the square within the circle. Okay, so we're going to be using this in coordinates. So we're going to have x and we're going to have y. This point here will be x, y. This point here will be x, negative y. This point here will be negative x, negative y. And this point here will be negative x, positive y. Okay, so basically, this distance is going to be x, and this distance is going to be y. Now, the constraint that we've been given is the circumference is equal to 1 meter, which means the circumference of this circle is equal to 1 meter. So, what we're going to do is we've got a sign, and the sign is the shape of a circle, and we've got a sticker. And we want to know what's the biggest sticker, like area-wise, we can put on this sign without it hanging off the edges or without it being too small for the sign. So we want to stick a sticker on a circular sign, like putting stop on a red circle sign. Anyway, that's what we're going to try and do today. Optimize the biggest sticker we can put on this sign. Okay, so we're going to use a bit of triangles with this. Hopefully you don't hate them too much. So what we're going to do is we're writing down our area because we're going to be maximizing our area. And our area is going to be equal to 2x multiplied by 2y, or which is equal to 4xy. Now why is that's because we have 1x and then we have another x. And then we have a y going this way, and then a y going this way. So we have two y's that make up the width, and two x's that make up the length. So that's why we've got that. Okay? Because the area is length times width. And now we've got a problem because we don't know how to work this. Well, lucky. So what we're going to use is all we've got given is the circumference, and we don't know anything else. So we have to use the circumference to find x and y. Now, we can use the circumference to help with the radius, and once we have the radius, we can find our y and our x. So that triangle is going to look like this is going to be our x, and this is going to be our y, and this is going to be our radius. Okay, and so think of it when you're going to be using Pythagoras. So that's c squared equals a squared plus b squared. That's the same as writing r squared equals x squared plus y squared. Therefore, if we rearrange it to, because we need either x or y, we can't just have r. We're going to bring y over this side, so it's going to be y squared equals x squared, or r squared minus x squared. And to find y on its own, we're going to square root both sides, and we're going to get y is equal to the square root of r squared minus x squared. Okay, now we found our y value. We're going to sub that back into the area. So the area is now equal to 4x. And what do we have for y? The square root of r squared minus x squared. Okay. Now that we have that, what we're going to do is going to get rid of the square root. How do we do that? Well, we square it all. So the area is going to be equal to this whole thing. We're going to square it. That's going to give us 4 squared is 16, x squared is x squared, and the square root of x squared, that cancels, and we're just left with r squared minus x squared to the power of 1, because we got rid of the square root by squaring it. Okay, so we're going to multiply the 16x squared into each one of these. So that's going to give us 16x squared r squared minus 16x to the power of 4. Okay, and that means now, well, we don't know what r is, so now we've got two variables. So how do we find r? Well, we use the circumference. So the circumference is equal to 2 pi r. Now we said that circumference was equal to 1, so 1 is equal to 2 pi r. Therefore, r, if we divide 2 pi by both sides, is 1 over 2 pi, which is equal to roughly 0.16 meters, which is going to be equal to 16 centimeters. Okay, now we're going to keep it in meters for the sake of this. So this is going to look like 16x squared multiplied by 0.16 squared minus 16x to the power of 4. Okay, so if we 0.16 squared multiplied by 16, that's going to come out as 0.41x squared minus 16x to the power of 4. Now, I prefer to choose the easy way on this, and the easy way that I find is, well, we have x to the power of 4 and x squared. You can't really deal with these the way I've been shown easily, so I usually just change them and write over here something like x squared equals, we're going to use alpha. So now that will look like 0.41 alpha, that's a bad alpha, minus 16 alpha squared, because x squared is 1 alpha, therefore x to the power of 4 is alpha to the power of 2. Okay, that is our area. Now we can work with this really easily. So we find the derivative. If you watch my other videos, you know why we use the derivative, because we're looking for the maximum. And the derivative of this will be 0.41 alpha minus, well, 2 times 16, that's 32 alpha. And we let this equal 0, and we rewrite this out. And basically, if we rearrange it, we get alpha equals 0.41 on 32, because we'd add both sides, 32, and then we'd oh, what am I doing here? That isn't right. I've got to get rid of that when we find the derivative. Thanks for pointing that out. But this is what alpha equals now. Anyway, so alpha is equal to x squared. So x squared technically is equal to 0.41 on 32. So if we want to find x on its own, we have to square root 0.41 on 32. That means x is equal to, if you put that in your calculator, roughly 0.11 meters, which is 11 centimeters. Okay, and before, when we had that equation of y is equal to the square root of r squared minus x squared, well, y is equal, if you sub those values in, of 0.16 for the radius, square that, minus 0.11 squared, which is x value, y ends up being 0.11 meters. Okay, so that means that x is equal to 0.11 meters and y is equal to 0.11 meters, which means it's a square. The sticker is going to be a square. And if we put this into the area formula, which is we've established is 4xy, we're going to get 4 multiplied by 0.11 multiplied by 0.11. It is going to spit out 0.05 meters squared. Now you can convert that to centimeters if you want to, but I'm going to leave it there. That is the area. If you made x a little bigger and y a little smaller, then this area would be a smaller value. And if you made y a little bigger and x a little smaller, then this would be a smaller value. What this means through this process is that this value here is the maximum area, the biggest, the most amount of area you can get out of for this square, out of having a circle that has a circumference of 1 meter, if that makes sense. Anyway, hopefully it does. Thanks for watching this video, and have a good day.